Hello, my algebra students. Today, we are going to be working on graphing some quadratic functions, and all of those functions are going to be in factored form. So, would you please have your book out and open it up to page 94. For our warm-up today, we've got this parabola that's already been graphed, and it's got 3 points on it that are labeled, and it's in function or in factored form over on the side there. We've got it written as w of x is equal to x plus 1.6 times x minus 2, and we want to be able to find all these different variables. So we know some of these already are going to be pretty easy to find out because a bunch of them are zeros, right? On the x-axis, we know that the y part of each of those ordered pairs are going to be 0. So for instance, in this ordered pair A, B, I know that the B part of that has to be 0. And I know that in CD, the D part of that, let me put that up above that ordered pair, has to be 0. And on the y-axis, since I didn't go sideways at all, I know that the x part of it, the E, has to be 0. To find the x-intercepts, I can use what we did in the last lesson and take that factored form to figure out what the x-intercepts would be. So if I rewrite that w of x equals x plus 1.6 times x minus 2. And I would ask, what would make this factor equal to 0? Well, that's going to be x equals negative 1.6. And what would make this factor equal to 0? That would be x equals positive 2. Now, looking at the fact that this parabola has one of the x-intercepts on the positive side of the x-axis and one on the negative side of the x-axis, I know then that, first of all, I should have left myself a little bit more space, but I know that the A has to be that negative 1.6 because it's going to have to be a negative number. So that's what the A has to be. Then the the C has to be the 2. That has to be in the positive part. That's this one right here. So now we've got the A and the B taken care of. We've got the C and the D taken care of. To figure out what this last number is, that F right there, which happens to be the y-intercept, I know that the x part of that ordered pair is 0. So I just need to put a 0 in for the x's in my factors and figure out what the y would be. Remember that w of x is really equal to y, so I would put in 0 plus 1.6 and 0 minus 2. Well, 0 plus 1.6 is just 1.6, and 0 minus 2 is just negative 2. 1.6 times negative 2 is negative 3.2. So that's what the y part is. So w of x, that's just another way of saying y equals 3.2 when the x was equal to 0. So that means that the f part of this ordered pair, that f variable, is going to be negative 3.2. Okay. We are going to be graphing 2 different parabolas. This is now on page 95. They have 2 different tables set up for us. One of them is for this f of x function, which is x times x plus 4. Again, that's in factored form. The other one is g of x, which is x times x minus 4. Very similar looking functions. And I've got these 2 tables, and again, some of the numbers are already filled in for each of those tables. And I want to get the rest of the tables filled in, and it does ask us to find the x-intercepts, the vertex, and we're going to be able to take a look at the graph once we've got all of that information in there. So this is just a lot of number crunching, right? You should have a calculator available if you want to, but we can do a lot of this probably just in your heads. Let's just take care of everything with that f of x function first. So if I put in all of these different numbers into this f of x function right here, right, we're working on this one. So -4 times -4 plus 4. Well, I don't even care about the -4 up in front because -4 plus 4 is 0. 0 times anything is going to give me 0. If you are using a calculator, you can absolutely go ahead and type this in and then just keep substituting in different numbers for where that x is in both spots. When I put in a -3, I'm going to have -3 times -3 plus 4. And again, inside the parentheses, -3 plus 4 is 1. 1 times -3 is going to give me -3. Okay, I want you to notice that right here, I have some symmetry already. That tells me that this is going to be my vertex, and I'm seeing some symmetry, so I should know what's going to happen when I put a 0 in for the x. And again, I don't even really need to do a whole lot of work, because if the x is 0, do I even really care what I'm going to get inside the parentheses? 0 plus 4 is 4. Okay, so who cares? Because 0 times anything is going to give me 0. And right there, symmetry, right? Got the same thing. When I put in a 1, I should know I'm going to get a 5 there, but I'm still going to do the math because that's what we do. When I put in a 1, I'm going to have 1 times 1 plus 4. Well, 1 times 5, yep, that's 5. We knew that. Okay. At this point, I don't know what the rest of those are going to be because I ran out of numbers that are given to me to match them up with. So I have to do the rest of these on my own. And we're okay because we're smart. So I'm going to put in 2. 2 times 2 plus 4. Inside the parentheses, I've got 6 times 2, 12. Put in a 3. So I'll have 3 times 3 plus 4. So inside the parentheses, I've got 7 times 3 is 21. And it makes sense that those numbers are increasing, and it should have been smaller than that 32 that was given to us. And then we're going to put in a 5. And this better be bigger than that 32. So I'm going to have 5 times 5 plus 4. 5 plus 4 is 9 times 5 is 45. Okay. So that's my f function all figured out. We found the vertex. The x-intercepts, we should be able to find that also. The x-intercepts, remember, that's where the y values are equal to 0. So that will be right here and right here. Okay. So we can move on to the g function. Again, very similar looking, but we've got a subtraction in here. They have a -5 already figured out for us, so we're going to put it in -4. So I'm going to have -4 times -4 minus 4. -4 minus 4 is -8. -8 times -4, 2 negatives multiplied together give me a positive. That's going to be 32. When I put in a -3, both of those are going to change into -3s. -3 times -3 minus 4, -3, and you could certainly do a keep change right here. -3 plus -4 is going to be -7. -7 times -3 would be positive 21. And again, it should make sense that that number should be in between 32 and 12. So those numbers all seem to make sense. Now I need to put in a 0. And again, 0 should be the easiest one to substitute because 0 times, oh, I don't care what garbage goes in here because 0 times anything, 0. When I put in 1, 1 times 1 minus 4, 1 minus 4 is going to be -3 times 1, -3. Oh, look, I found a match. That's important. when I put in my 2, I'll have 2 times 2 minus 4. 2 minus 4 is negative 2. Negative 2 times 2 would be negative 4. That looks like it's my lowest point. That should be my vertex right there. Okay. Since we found a place where we've got some symmetry, I should know what to expect when I put my 4 in. When I do this substitution, I'll have 4 times 4 minus 4. Got a bunch of 4's here, but inside the parentheses, 4 minus 4 is 0. Well, 0 times anything, 0. And again, there's my symmetry. That matches up. That's good. And then when I put in 5, I'll have 5 times 5 minus 4. 5 minus 4 is 1, times 5 is 5. And again, I've got, that matches up. Okay? And we have to find our x-intercepts. That's where the y value, or the output, the g of x, is equal to 0. So right there and right there. Okay. Then it says plot the points from the table on the same coordinate plane. Consider using different colors. So I would ask you to do that, and if I was in class with you, I would absolutely say, hey, let's take the time and do that. Because I'm not there, I'm going to say, look, it's magic. I have it done. All right, so the f of x function, I should have used red marker for the g of x function so it could match. The f of x function, I obviously did that on purpose. I've got in blue to match up those points. We've got the vertex is at -2, -4. And I have to move this up a little bit. That's right here, -2, -4. And we've got our x-intercepts are right there. So one of them we knew was going to be at 0, 0, and the other one's at -4, 0. In the g of x function, which has the red dots, the vertex is at 2, -4, which is right, I'll use green on here. 2, -4 is right here. And 4, 0 is one of my x-intercepts, and the other one is also at 0, 0, right here. So they kind of cross over, okay? It does say to make a couple of observations, so I want you to notice a couple of things. First of all, both of the vertices, the vertex of each of them, is shifted down 4 units. They're both at -4. They both go through the origin, and both of these parabolas are a reflection of each other, right? If you would reflect it over the y-axis, we've got a reflection of each other. But again, we could even see it just from the functions that we started with. They are going to be very, very similar. And you can even see that from the numbers that we had in the table, right? You can see the similarity there. Okay, so would you please turn the page to page 96 then? And we're going to talk about what we need so that we can actually sketch a graph. We've got 3 different equations, 3 different functions given here, f, g, and h. We're supposed to predict. We shouldn't have to be guessing here, though. We know we can find the x-intercepts of each one of these functions. And then we should also be able to find the x-coordinate of the vertex of each of them. They're not even asking us to find the actual vertex. They're just asking us to find the x-coordinate of that. So, finding the x-intercepts. Remember, that's when we take each of the factors and make those factors equal to 0, right? So I would ask for each one of these, what makes this equal to 0? Well, that's -3. right? And if it's an x-intercept, that means that we didn't move up or down at all. We're staying right on the x-axis. So this would be at -3, 0 for one of them. And then for the second one, what makes that equal to 0? X minus 5? Well, 5. 5 minus 5 is 0. To find the x-coordinate of the vertex, it would be exactly in the middle between those two x-intercepts. So you could graph those and kind of count in between to find that middle number, or I think it's easier, find the average, right? Add those two x-intercept numbers, don't worry about the zeros, just the -3 and the 5, add them together and divide by 2. -3 plus 5 is 2, divided by 2 is 1, right? All you need there is just 1. That means that the vertex would be on x equals 1. Okay, for the g of x function, this is in factored form. It's just that this first factor doesn't have any addition or subtraction. It's just 2 times x. So what makes that equal to 0? 2 times what equals 0? 0, right? So the x part of that is going to be 0, and the y part always going to be 0. The second part, what makes that equal to 0? What number minus 3 equals 0? Well, that's 3. And again, I want to know what the x-coordinate of the vertex would be. What's halfway in between 0 and 3? Well, 0 plus 3 is 3. Divide by 2. That's 1.5. 1.5. And for h of x, there is something a little bit unique about this one, but it's still easy to find the x-intercepts. What makes this part equal to 0? What number plus 4 equals 0? Well, that's -4. And what makes this part equal to 0? 4 minus what equals 0? Well, that would be 4. What's halfway in between -4 and +4? Hopefully you don't even have to do any math on that one. That's just going to be 0. If you want to do the math, go right ahead. -4 plus 4 is 0. 0 divided by 2 is 0. Okay? The thing that I want to point out that's a little bit unique about this one is the fact that in this second factor, it's 4 minus x. The x is actually negative on this one. And if you multiplied those together, if you did either the diagram kind of multiplying or our distribution, we would end up with a -x², which is going to be different than what most of our parabolas have looked like so far. So now number 2 says use graphing technology to graph those functions. I don't need you to take out your computers and graph those. I have them all graphed for you. You're welcome. So here they are. And this is right from Desmos, which I know makes this look a little bit stretched out and kind of wonky. I didn't really change all my viewing window and everything, but I do have these in the same order that this started with. So that first one, that x plus 3 and x minus 5 is the red graph. It's crossing the x-axis at -3 and +5. And you can see that the vertex is right here, which is there at 1, right? That's what the x value is. For the second one that we have, that g of x function, we said that it was going to be at 0, 0, and 3, 0. And that's, I'll use the colors that I guess got graphed on here. So 0, 0, and 3, 0. And we said that that vertex then would be at 1.5 for the x value. And that's where it is, right? It's right in between those two x values of the x-intercepts. Now, for that h function, this is what I wanted to point out to you. take a look at what this graph looks like. That green line, the green parabola, I should say, it's not a line, that parabola is upside down compared to the other ones. It's because that subtraction with the x is what's going to flip that one upside down. But it's crossing at -4 and at +4. And my vertex, the x part of it is at 0. Not the y part, right? We didn't do any work to try to find what the y value was for any of the parabola or for any of the vertexes, but we can find the x part of the vertex for all of these just by finding the average of the x-intercepts. Okay, still on that same page for you, it asks you to do one more graph. It gives you that expression, x minus 7 and x plus 11, and it asks you to find the x-intercepts and the vertex. Think about how the y-coordinate, how to find the y-coordinate of the vertex. So let's think about what those intercepts would be for the x-axis. So for this, what makes that equal to 0? Well, that would be at 7. And what makes this equal to 0? That's going to be at -11. Right? So I could graph those two. And I know that this graph isn't necessarily the easiest one to graph on. Look at how this is counting on the x-axis. It's counting by 2's on the x-axis and is counting by 20 on the y-axis. I know that that seems a little bit extreme, but we're going to get some pretty big numbers for this. So 7, 0 is going to be right here. And -11, 0 is way over here. Right? That's my x-intercepts. The vertex would be halfway in between those two. 7 plus -11 would be -4. Half of that would be -2. So I know that my vertex, the x part of it is going to be at -2. I need to find the y part of that because this time they're actually asking us to figure that out. If the x part is at -2, that just means that it's going to be somewhere on this line. Okay? I just need to substitute -2 in for the x. I know the x. And I've got this factored form. I'm just going to put -2 in for the x's. I'll switch colors here so we can keep track of this. When I put -2 into this, right, I'm going to have -2 minus 7 and -2 plus 11. -2 minus 7 or -2 plus a -7 would be -9. And -2 plus 11 is going to be +9. Well, that's going to be -81. Right? So that point, this is why they had to count by -20 or by 20s on this. -81 is going to be way down here. Okay? So that's 3 things that we've got figured out for that. And then I should figure out one more thing. I can find the y-intercept. To just get one more thing before I graph this. The y-intercept is pretty easy because that's when the x is equal to 0. So let me do one more thing. If I substitute 0 in for the x's, so I would have 0 minus 7 and 0 plus 11. 0 minus 7 would be -7. And 0 plus 11 would be 11. That's going to be at -77. So that is going to be at 0, -77. So 0, -77 is going to be like way down here. Okay, so I can try to graph this, but I have a much better graph that I'm just going to uncover for you. But the I missed a little bit there. But hey, look, magic. There's a much better graph for you. So there is my graph. Okay? And if I was there with you today, I would do the Are You Ready for More? But I'm not there. So this is not in your book, so I just need you to be watching this and kind of following along. If I've got this quadratic function, k of x is equal to x minus 100 times x plus 20, how would you explain to a friend how to do all of this different stuff? Could you find the zeros of the function? The zeros of the function are where it crosses the x-axis. Very similar to the x-intercepts, right? It's just the values where it crosses the x, what makes it equal to 0, right? Where it crosses the x-axis. So what makes this equal to 0? Well, that's 100. What makes this equal to 0? That's negative 20. The x-intercepts, that would be the actual ordered pairs. So I would use those zeros to write those as ordered pairs. So I would have 100, comma 0, and the other one would be negative 20, 0. Then to find the x-coordinate of the vertex without graphing, that means don't go to Desmos, don't try to find it that way, just use this information. I want to know what's exactly halfway in between 100 and negative 20. Well, 100 plus negative 20, that would be 80, and half of 80, or 80 divided by 2, would be 40, right? That's what the x-coordinate would be. That's what the x part of the vertex would be. Finding the y-coordinate of the vertex without graphing would mean I'm going to take this number and substitute it into both of the factors. So I would put 40 minus 100 and 40 plus 20. Again, neither one of those are very difficult, but you could certainly use a calculator. 40 minus 100 would be negative 60. And 40 plus 20 is going to be positive 60. And then we just have to multiply those. Well, they're different signs, so I'm going to get a negative answer. So it's going to be negative 3,600. That's what the y part of the vertex would be. So now I would know actually what the vertex is. It would be at 40 and negative 3,600. It's a good thing they're not asking us to actually graph this because, holy cow, that would be a difficult one to graph. The y-intercept of the graph is when the x is equal to 0. So I just have to put in a 0 in each of those factors. So I would say 0 minus 100 and 0 plus 20. Well, that's negative 100 times 20, right? That's going to be negative 2,000. That's, again, holy cow, who wants to graph that? That would be what the y part is. But I would want that, since it's actually asking for the intercept, I would want that as an ordered pair. Just like the x-intercepts, we wanted ordered pairs. So the x was 0, the y is negative 2,000. Okay. In your book, they have a really nice lesson summary. You can certainly look that over and read through any of that if you need help with it. And the homework today is going to be 1 through 10. If you need any help, feel free to send me an email.